Hello, this is a study about predicting employee attrition. This is as part of the project for programming machine learning applications. The presentation is outlined in following subsections. So we'll have a brief overview of data set first, followed by some visual exploration. We'll also speak about the pre-processing techniques applied on the data, experiment with some of the modeling techniques, and conclude with the final analysis. So this data set is available on kaggle.com. It is a fictional data set created by IBM data scientists. It has about 1500 instances, 35 features. It constitutes of categorical features, ordinal features, numeric features, but we have one target variable and it is highly skewed, and as you can see on the graph at right, that only about 16% of the values are yes. Yes means the employee has left the company, so this would be the class of interest to us. So visual exploration, when we think about it, the first thing that comes to mind is what affects attrition. So you can see some of the variables have been plotted against attrition. So we see that all the orange bars here, they denote the attrition class yes. So this is the part that is of interest to us. So we can see that job level 1 is seeing the most amount of attrition, and over time yes is seeing most amount of attrition. So are the lower monthly incomes and the age group between 25 to 35. Now although job level is not ranked, but if we plot job level against monthly income, we see that monthly income increases from 1 to 5. So we can safely assume that job level is ranked in the order of 1 to 5. Here are some more variables plotted against attrition. So job role, you can see laboratory technician and sales representative and human resources, they are seeing high amount of attrition. So so is the environment satisfaction level 1. So level 1 is the lowest level and the level 4 is the highest level. We can see that the attrition rates smooth out as the level increases, which you would normally expect. However, the gender is an interesting variable here. Traditionally, it has been known that females are not so quick to leave any company, but we can see here that female and male attrition rates seem to be almost equal. And if we verify it with numbers, female attrition rate stands at 14.5% and the male attrition rate stands at about 17%. So we see that both the gender is sort of not affecting the attrition. From here on to the pre-processing. So the first thing we did was, since we had a lot of ordinal variables, we converted all of them into categorical, and there were some irrelevant variables as well, like over 18, which had only a value of yes. Standard hours was always 80. So we have removed such irrelevant variables. Then we scaled the numeric variables with robust scaler. We used this particular scaler because it scales within interquartile range, which is then become little less prone to outliers. Then we created dummies for all the categorical variables. We also created an oversampled training data set because we know that our class target variable is skewed, and we used the SMOT function from IMB learn package to achieve the same. So if you see on the bottom right, we have used 7 nearest neighbors to constitute the artificial instance. Now coming to the models, the first models that we created was RandomForest. We experimented with different parameters, and we also performed a grid search cross-validation to search for the best parameters. We also did one model with the oversampled data. On the right, you see a table which predicts the accuracy, precision, and recall for all of these models. So we see that for class no, the predictions are about the same. They vary between 0.85 to 0.89, and the recall varies from 0.89 to 0.95. However, the precision and recall values for the class yes, they are quite low. The precision varies. They seem to suggest that we are only about creating a random guess for class yes. However, our overall accuracy increases because we are predicting the no values with greater confidence. Other thing that to note here are the important features that are taken into consideration by this model. So overtime has been rated the number one feature, followed by environment satisfaction and marital status. Then stock option level, that is also one of the preferred features. Then relationship satisfaction, and it also gives some importance to work-life balance. However, the interesting thing is it gives importance to gender male as well, while we saw that the difference between male and female attrition rates is very small. While it is not giving that much importance to monthly income and age, which seemed like good predictors when we did the visual exploration. The next model, which is the K-NearestNeighbor. So we created two types of models and repeated those two models on the oversampled data. The first model that we created was with all the features included, and the same distance metric was used for categorical and numeric features. Then we separated the categorical and numeric features and created two KNN models with different distance metric for in each of them, and then we stacked those two models by averaging the probabilities across each class and assigning the class with greater probability as the final class. Now both of these models were repeated on the oversampled data. Now on the right, as you can see the same metric as we used in RandomForest for KNN. We see that the accuracy of KNN models, they range between 0.77 to 0.85, when the stacked model, so we see that the stacked model with when we have used the different distance metric is not giving much improvement over the normal model. The precision values in the normal model were 0.88 and 0.84 respectively, but the recall value for class yes is quite low. So the problem across the KNN model is that it has quite a good amount of it has greater precision in predicting all of the classes, but the recall values are really low. So in essence, it does not seem like to be a good model. The third technique that we used was logistic regression. So we created three models, one with the defaults except the class weight was taken to be balanced. Then the other one was trained on the oversampled data, and the third one was the grid search with tenfold cross validation to find the best values of the parameters. And as you can see on the table on the right, again prints the same metrics for all of the three models. So we see that the accuracy is lower. In terms of compared to the other models, but we have a good accuracy with the tenfold cross validation model, and we have good precision values, and the recall is the best so far. We have about 0.42 of recall for class yes, and the recall for class no is 0.96, and the overall score for no is 0.92, and the overall F score for class yes is 0.53. So logistic regression seems to be performing better. Now let's look at the variables that it takes into account for giving us these predictions. So we see some familiar variables like distance from home, years in current role, years since last promotion, job involvement, environment satisfaction, job level, then stock option level, overtime, work-life balance. So these are variables that you would intuitively think to be affecting the employee's decision to whether to stay or not in the companies. This seems to be more in tune with the human intuition. The fourth kind of modeling technique that I tried was stacking these models together. So the first one that I created was with LogisticRegression and RandomForest. It had an overall accuracy of 0.88 with the precision values for class yes as 0.7 and class no as 0.9. The recall for class yes has seemed to have increased a little bit with 0.52. So we are just above the random guess. And the recall for class no is as always great. The F score is little better. It's 0.59, almost 0.6 and 0.93 respectively. The second model that we created is LogisticRegression plus K-NearestNeighbor. It gives an overall accuracy of 0.85. And the precision and recall, the precision values are close to what we observed in the other stack model, but the recall becomes quite low. That's because the KNN had a lower recall value, so it has pulled the recall values of the stack model also low. The third is a voting classifier which was created with all of the three models. However, it does not give great precision and recall values for class yes, so it was not accepted as the final model. To compare all of the models together, I've created this ROC curve, and so we can see that the line in red is for KNN and it has the least amount of area under the curves. So this is the least performing model as we had expected. Other models, the one in green, which is the LogisticRegression, the one in orange is the LogisticRegression plus RandomForest, and the third in the cyan is the LogisticRegression plus KNN stacked model. They are all performing comparably. However, the RandomForest is not performing that well. It is at 0.77. However, we have, through all this analysis, we have seen that all of the models have very low recall values for class yes. However, the other precision and recall values for other classes are pretty good. So in essence, we can say that we can predict with confidence what if we predict somebody that is leaving the company, then he probably will leave the company. We predict that with about 0.7 to 0.8, 70 to 80% of confidence, but we do not catch all the employees that would be inclined to leave the company. In terms of the features that stand out, stock option level, overtime, environment satisfaction, job role, they stand out over other features. As we would have expected, contrary to our expectations, monthly income is not that great predictor, but job role is. Stacking and oversampling are not giving us much of an improvement. We can take the LogisticRegression model as our final model here. However, there is scope for a lot of improvement, and since stacking the models and experimenting with different set of features is not giving us that much of an improvement, we can now look towards some of the anomaly and novelty detection techniques which are generally used in the fraud detection method, and we can see if they provide us some of the improvements. This concludes the presentation for this case study. Thank you.